Hi guys, this is Ms. Caspero, and this will be a different kind of video than what I've done before because there is nothing that we're going to be doing by hand on regression. We're going to let the calculator do all the work. So I've made some really detailed slides for this, but we do have to get some vocabulary out of the way. Bivariate data. Data on each of two variables, where each value of one of the variables is paired with a value of the other variable. So where you have an X and a Y, this would be bivariate data. You have univariate data, which is when you're just dealing with an X, like mean, median, and mode. But bivariate data is what we're going to be dealing with now. Regression is a statistical method that attempts to determine the strength of the relationship between one dependent variable, usually denoted by Y, and an independent variable, usually denoted by X. You can get regression graphs on many different types of functions, not just the lines you did in Math 1. All right. Here are the general parent functions to use in Desmos. So now you know why we did parent functions in Unit 1. It was because you needed to know the basic functions that were all going to be used. So once you find out what the data looks like, you're going to try to figure out which of these is the closest to the data to plug in. And I've got lots of screenshots for you here. All right, linear regression just is getting a line. You drew scatter plots and found the equation line that lies as close as possible to all of the data. Okay, we had positive correlation, negative correlation, and approximately no correlation at all. The correlation coefficient was between -1 and 1. This is -1. Well, it would have to be a lot closer together to actually be -1. But this is the negative and this is a positive. And as close, what I meant to hit. When they get very, very close together and make almost a straight line down, that is where you get to 1, or -1. And when a straight line this way is a 1. Not much of it's a wider correlation when you say this is like a 0.75, so, or -0.75. It's not quite that, it's very obvious it's a linear, and it's very obvious it's negative, but it's not that close together. The table shows the number, this is another linear regression. The table shows the number Y in thousands of alternative fueled vehicles in use in the United States X number of years after 1997. To use Desmos, you must have a vertical table or enter the data in the spreadsheet. So you can do it in a spreadsheet and then paste it, or you can just type it into Desmos. And I think I've been showing you guys that in class and on videos. But you would have Desmos, and you would have a calculator. You would have a table that we would be adding. A table. Take rid of that. And you just put in your values there. Okay. What was it? 0 to 80? Yes, 0 to 80. All right, I do have these filled in on the next slide, I believe. 0 to 80. And you just put your values in. It's hiding right behind my pause button, so I can't get to it. You put in your table, just like this. This is what I was trying to do. 0 to 80, 1 to 95. And you type in Y sub 1 with a little tilde. If you just type in Y1, it will automatically drop it to the sub position, which it needs to match up with this table. This R value right here is your correlation coefficient. And you can see that this is very, very close to 1. It's very, very close. This would be the equation of the line that it's getting you. Y equals 40.9x plus 262.8. Okay, and if they went to the hundredths, say hundredths. No, didn't say. If it says hundredths, then you would definitely go a little bit bigger than what we had. I don't know where I got the 81. It should be 87. But it will definitely come out for you. A quadratic regression. So you're going to type the table into Desmos again. You add. And where I'm showing you the add part of this is right here. Add a table. Okay? That's where we're getting the add from. Okay? Click it, select table, and put all of your values in. Okay? Now, we were told here, or I was telling you, it's a quadratic, that we knew we were doing that. So we type in a general equation of the quadratic to see how well it fits. Okay? Notice how close the r squared is to 1 for the quadratic, but it's 0.05 for the linear. So I just compared them to see which one was the best fit. All right. It looked pretty straight when I had pulled it out. But turns out this would be the best fit because of that 0.999. And that would be your equation. Ax squared plus bx plus c. Try to put as much information on these slides as possible so that you'd be able to come back to them and check. All right, exponential regression right here. Set your x-axis and y-axis. Make sure you're in radians or degrees when we get to trig, by the way. Make sure you're in the right one. Set your x-axis and your y-axis values so that you can see all of your data. Insert the table again to put the data in. And the points will show on the graph. Your x, you need to make sure that you can cover your x from 0 to 60. So I put it in from negative 15 to 75. This has to be from at least 0 to 110 or something. So it came off that way. And this is what it looks like, which looks a little curved. The data has a curve in it, so we can ignore linear. If it were quadratic, it would be turning back upward. It would come down like this and then coming back up. But it's not. An exponential function rises or falls, keep hitting the wrong thing, rises or falls quickly in one direction, just like this graph. So you are looking at the exponential here. Here's your exponential, y, and then that little tilde. If you're wondering where to find that, it is on your, I believe I've shown it to you before, but let's go back and pick it up again. It is, I can get there. There we go. It is on your screen here, on Desmos, right next to the brackets at the bottom. Okay? Just that little tilde. All right. Wrong one. Okay, a, b to the x, and you hit the 1 again, and it'll drop it so that it will match. I wanted to go up on the Desmos. This is not the real Desmos, sorry. So it will match all your points here. R squared is very, very close to 1. So here is your a, b to the x. It's not difficult to get these functions that will work because the calculator's doing them all. All you've got to be able to do is type in your table and make sure you can set your graph so that all your points will show. Other than that, pretty much Desmos is going to crank it out for you, which is very nice. Sinusoidal functions are used to describe things that repeat over and over. Examples include sunrise, sunset, same time about every day, distance from the ground of a basketball being dribbled, So it's 0, and then it's up to your hand, and then it's 0, and then it's up to your hand. It just keeps repeating. The distance from the ground of someone on a Ferris wheel. You're up at the top, then you're down at the bottom. You're up at the top, then you're down at the bottom. That type of thing. Low tide, high tide. That's also one that just keeps repeating over and over. Here's one. The table below shows the number of kilowatt hours K in thousands used each month for a given year by a hangar at Cape Canaveral Air Station in Florida. The time T is measured in months. Okay, so right here we've got a table of information that we've got to put in. And don't forget to change your domain on your x-axis and your range on your y-axis. So here we go. We went in and my domain only has to be 1 to 12. So I went 0 to 15 just to kind of get it all done. And then the lowest point here was 59. So drop it down to 50. And the highest point was 106, so we took it up to 110. And here's what the graph looks like. Comes down, goes up, and that's very definitely sinusoidal. Okay? So, you will use the general function that you've got, a sine, and in parentheses, b, x sub 1 minus c, and then close 2, plus d. And here it goes right there. You've got your a, b, c, and d. 23.9 sine 0.5 x minus 5.1 plus 82.4. It gives you a perfect equation for it. So you can see how it's very nice to have Desmos involved in this. All of these graphs are the different types. See which ones look like good possibilities to try. And your R-squared is a good indicator of what best fits. That would be a cubic graph. There are your sinusoidal graphs, exponential growth and decay, linear, and your quadratics. Okay. I'm going to catch y'all on the next video for residual.